So in this video, we are going to put together everything we've learned about polynomial factoring and polynomial division to completely factor a polynomial. So this example says we are going to completely factor the function f of x equals 5x to the fifth power plus 29x to the fourth plus 59x cubed plus 107x squared plus 156x minus 36. That's a mouthful. Given that x equals -3 is a zero of multiplicity 2. So that's going to allow us to get started. Obviously, the strategies we know for factoring, like the Xbox method, grouping, those are really the only strategies we know, aren't sufficient for a polynomial like this. So we're going to need to use division based on the information that we're given. It's also worth noting that this could be asked differently. It could be told that x plus 3 is a factor with multiplicity 2, though we don't generally speak of factors having multiplicity, so it's more common to see it written as a 0. We're going to get started using synthetic division. As I said before, these are all linear factors, so that's really useful to avoid having to use polynomial division, polynomial long division, more than once. So we're going to copy down -3. This is the 0 we have. And then our coefficients are 5, 29, 59, 107, 156, and -36. And now I want to say out loud that when we divide, use synthetic division for x equals -3, that's giving us a factor of x plus 3 that will then be carried down to our final answer. So we carry down our first number, we multiply by -3, that's -15. I encourage you at this point to pause the video and see if you can finish this step on your own. So 29 minus 15 is going to be 14. I'm going to need to grab my calculator. Some of these numbers can get big. So 14 times -3 is -42 plus 59 is 17 times -3 is -51 plus 107, 56 times -3 is 168, excuse me, -168. We add that to 156, we get -12, which of course gives us +36 and 0. Now, we're going to do this process again because we're told that this is a 0 of multiplicity 2. So we're going to immediately set up a second set of polynomial synthetic division, and this will give us a second factor of x plus 3. So again, carry down our 5 times 3 is -15. That's -1 times -3 is +3. That's 20 times -3 is -60. It's -4 times -3 is 12 and 0. Now we've quickly run out of space. Nothing says that this process is done quickly. If we follow it step by step, it hopefully won't feel terribly difficult, but it doesn't mean it's going to go very quickly. So I'm going to erase the work here, and I'm going to write down our function as we know it now. So f of x equals, we have two factors of x plus 3, so that's x plus 3 squared. We've divided out two factors of x, which means our greatest power is going to be 2 less than x to the fifth. So we have x to the third, so that's 5x to the third minus x to the fourth plus 20x. Hold on a second. That should be x squared, not x to the fourth. Forgive me. Plus 20x minus 4. And now we can get rid of this. Now that we've got what we need. And we want to keep going. So notice that we have 4 terms here. Whenever we have 4 terms, it's a good idea to try factoring by grouping. So we'll group the first 2 terms. We'll group the second 2 terms. Greatest common factor here. Again, good idea to pause, test your skills, see how much you've learned, and then continue when you've finished. So 5x cubed minus x squared. So we can take out x squared. So that's 5x minus 1 plus 4 times 5x minus 1. And now our greatest common factor for these 2 terms is 5x minus 1. We have 5x minus 1 times x squared plus 4. And then we want to carry down the factor that we haven't yet written, which is our x plus 3 squared. And now we're almost finished. The only thing left is to factor that x squared plus 4. Hopefully by now you've kind of picked up on this pattern, that if we have x plus a square number, we have x minus the square root I and x plus the square root I. So we can go one step further. So f of x is equal to x plus 3 squared times 5x minus 1 times x minus 2i times x plus 2i. And this is the complete factorization of that awfully long polynomial that we had before. Just to reiterate a few prior points, we can write our zeros of the function and their multiplicities. So we have -3 as a multiplicity of 2. This would be 1/5 as a multiplicity of 1. And then positive 2i and negative 2i are complex conjugates, and they also have multiplicities of 1. Now remember that we started with a 5th degree polynomial, 5 times x to the 5th. So if we add up all these multiplicities, 2 plus 1 plus 1 plus 1, we do in fact obtain 5, once again showing us that the sum of the multiplicities of the zeros add up to the degree of the function. So this has been an example. The first thing we started with, doing repeated division, because we were given a 0 with a higher multiplicity, is incredibly common and does help us get started, usually ending up in a place where we can use either quadratic factoring like the x method or factoring by grouping as we did here. This is a general approach to factoring higher order polynomials. For most of the examples we'll be doing in this class, we'll be given either a factor or a 0 to start with. If we didn't have that, we would need to rely on our rational root test to come up with some test values to determine which of those numbers are zeros, and that would give us a starting point instead.